Hello again, guys. Good afternoon, everybody. Good morning to those, and good night to everybody else out there. My name is Kevin, and on behalf of the Novedge team, we would like to thank you all for attending today's latest Novedge webinar series episode. For today's episode 66, we have with us Michael Günther-Geffer, who will demonstrate and showcase the capabilities of VSR Shape Modeling 2.0 for high-end surface modeling in Rhino. Today's webinar will be about 40 minutes long, and afterwards we'll have a live Q&A session where Virtual Shape co-founder Peter Salzman will also be on hand to answer your questions as well. Our presenter, Michael, is a CAD software expert with more than 10 years of experience in testing, supporting, and demonstrating CAD software. Before his start in Virtual Shape research 2 years ago, he was involved in the development of ICEM Surf and ICEM Shape Design. We are very honored to have someone of Michael's expertise on hand to present VSR. Let's see. So before I kick off the webinar, let me go over what we do at Novedge as well. If you don't know what we do, if you don't know, Novedge Webinar Series is brought to you in part by Novedge.com. As one of the largest online design software stores, we offer a huge assortment of software and tools that cater to virtually every designer's need. If you're interested in purchasing a copy of Virtual Shape's VSR Shape Modeling 2.0, it is available worldwide from us at Novedge as a digital delivery with zero sales tax. Feel free to contact our Rhino sales representative, Bob at Novedge.com. In addition, we've also created an online community called Rhino Jungle, where designers of all skill levels can discuss industry trends and share their work. Signing up for our professional community is a breeze, and with that, you'll receive a newsletter where we break down the week's hottest headlines. In addition, you can follow us on Twitter at Rhino Jungle. Secondly, we are fans of designers and innovators who break the norm. Every week at our Novedge blog, we feature interviews with these very game changers. To get some insight and to read about the tools they use, visit our blog today. In our next upcoming webinar, webinar episode 67, Autodesk Expert Elite and Catalyst.com contributor Brian Benton shows how AutoCAD sheet sets can do more than print your drawings. See for yourself how powerful it can be as a project management tool. For more details, visit our webinar page at novedge.com/webinar/67. And if you missed something, if you want to rewatch this and other past webinars, you can catch it all on our Novedge webinar series channels on both Vimeo and YouTube. Now, with that said, Michael, are you there? Would you like to say hi to all of our attendees? Michael?
Well, I'm here, but I think in the beginning, Peter wanted to say a few words, just 1 minute, presenting our company, who we are, where we're coming from, and what we are doing.
Cool. That's Michael, guys. All right, so in 3 seconds, I will switch over the presenters to you guys. All right, let's see. All right, here we go. Michael, I'm turning you into the presenter right about now. Enjoy, guys.
Okay, so you should see my screen right now. And do you see the Virtual Shape PowerPoint right now?
Yes.
Okay, then I'll hand over now to Peter. He's the CTO of this company, and he'll give you a short introduction to the Virtual Shape company.
Hello, everybody. I don't want to bore you too much with our marketing slides, but just a few words that you know where we are and where we are coming from. Virtual Shape Research is a software company developing and marketing CAD software, especially for freeform modeling and visualization, and we are located in close to Hanover, Germany. We are a team of developers. Right now we are 10 people, but we have more than 20 years experience in the development of CAD software, and we work for companies like ICEM, Dassault, PTC, and others. And our main product in the past was the product ICEM Surf. It's a product, I would say, where the majority of cars on the street today, the exterior and the interior surfaces are designed by ICEM. Just to give you a little bit of background. Besides the Rhino plugins you will see right now, we are also doing software development projects. So we were developing software for companies like Autoform. They are doing a sheet metal finite element simulation. We contributed to some architectural programs like Nemetschek Allplan. And in the last 2-3 years we also developed a lot of functionality for Autodesk Alias. I would say from the last 2 Alias releases, I would say about 50% of the new functions are from us. So this gives you a little bit of background. Michael will give you now a demo of our software, just a short overview about our products. Our flagship is the VSR Shape Modeling. It includes an analysis toolbar, which you could add analysis functionality to services like you can see on the right side of the car. We have also an embedded real-time renderer, and we can export the geometry to 3D HTML pages, which is called WebGL. And we can also show this 3D content on mobile devices like iPad or iPhone. All products are seamlessly integrated in Rhino, and for example the real-time renderer and the modeling, you can even model in real-time rendering environment. That means it's not one or the other. All the analysis functions are associatively, but I would say just enjoy the demo. It's better to see it live than on some PowerPoint slides.
Okay, now it's me, Michael, again, and let's say we jump just right into Rhino 5 with our modeling tool installed. This example you see of the car here, it's been developed in a car modeling workshop done by Jorge Biosca in Spain last year, and it was before Jorge was knowing our plugins, and so he was modeling this car just in Rhino without our tools. And in this workshop we faced some problems then with the pure Rhino tools when we were trying to fill this area here with surfaces. So let me just show the problems we were facing with the Rhino tools. We wanted to make a surface blend in the upper area here and then fill the four-sided remaining hole on the lower area with a simple surface. So when you're trying to use the blend surface on here, I'm just doing it, selecting the left and the right edge, then moving the right side up, using Rhino Object Snap to find the right space, aligning the edge here, moving the control points a little bit in so they don't cross. And the first problem you got in the Rhino blend is you only see the control points on the edges, you don't see the inner control points. But these inner control points are also important for the shape. All you've got here is you get a preview so you can guess what the shape would be like. But if you're now trying to analyze the blend you're just creating with the Rhino zebra function, like you usually do, it's here under Analyze Surface Zebra, it cancels the running command. Rhino can only run one command at a time, so you need to finish the blend first before you can analyze it. So let's do that again, creating the blend here, snapping, adjusting the control points. Okay, done. And now I'm analyzing the surfaces I've just created in Rhino with curvature continuity with the Rhino zebra function. And if I now zoom in here on the left transition, you see that the zebra is not continuous, so the quality on the left side is not the quality you'd like to have. And also if you have a look at the control points which have been created, first point, there are 4, while the input on the right side has just 3 and the left side 2, so these 4 are already too many control points than needed. And as you can see here, they are not well distributed, and this is actually causing the bad zebra and the bad light line, so this is not the quality you'd like to have. Okay, so doing the same now with the VSR tools. I'm using the VSR surface blend, which is this icon here in the modeling toolbar. I'm selecting the left edge, the right edge, and you can already now see handles in this area. These handles can be used to move the control points where you would like them to have, but these handles can also be, or they also have context menus. If I now go with the mouse over the handle, you can use the right mouse button to access this context menus. And now I'm going here to the shape section and using the partial option. And what it does, it takes the point on the left side, projects it onto the right side, so it brings it just into the position where you want it to have. And now I'm using the right mouse button context menu on the left handle here. And you see here a lot of continuity, and this is not the surface continuity, which you see in the main menu, curvature. It is the continuity with this edge is running out of this edge here. So if I'm setting this to position, it's now, this edge is free to go over to the right side, but the surface transition is still curvature continuity. Gonna move this a little bit away. Now you can already see, the control points of the surface blend here, which are nice and equally distributed. You can control all the surfaces you create or modify with the shape modeling toolbar in the VSR shape options. This menu here on the right is available by clicking on the blue eye here in the modeling toolbar. And there you can control, for example, if you want to see the control points or not, if you want to see the surface shaded or not. All this kind of display attributes for all VSR tools can be controlled here in the shape options. So this is an important function. You should keep that open if you're working with VSR tools. So now also a main difference, we are still in the creation process of the surface blend. And now I'm calling the VSR zebra, which is called light lines. This is on the analysis toolbar. It is this icon here, the black one. And it has different color modes. You can, for example, choose the one which looks like the Rhino one, black and white. You can choose colored ones. But my preferred one is this one here. And now one nice thing is you can just focus, you can zoom on the area you want to expect, and then you can move the handle. You don't have to rotate the geometry to get your light lines running where you want them to have. So I'm choosing just the Z direction for the moment. And if you're now taking a look at the light lines running over these three surfaces here where I created the blend, they're very smooth. And this is exactly the shape you want to have. This is this kind of light lines you'd like to achieve. Now in the surface blend function you can also see a lot of options, and one of them, a lot of VSR functions have an integrated analysis. And in this case, in the surface blend, I can switch on the matching, and it now measures the transition quality of the surface blend to its input surfaces. And you can see here now the curvature quality. This is perfect on the right side, and you got a small error here on the left side. When clicking on options behind the matchings, you can, for each side, you can control which mathematical analysis you want to do for the left and right side separately. So on the left side, if I'm checking position, it's perfect. Tangency, it's perfect. And if I'm curvature, you see the small error. On the right side, position, it's 0, perfect. Tangency, small error. Curvature, perfect. Okay, so now you might ask, why is the VSR surface blend not creating a perfect surface blend from the beginning? Well, to explain that, I'm just doing that by hand. I'm using now these handles to adjust the placement of the control points. If I'm doing this just with the left mouse button, it's only recalculating when I release the mouse button. If I'm pressing the shift button while moving the handle, it is recalculating instantly. So this is valid for a lot of VSR handles, so you might remember this. Press the shift button if you want an immediate result. Okay, so now I've made this left transition nearly curvature perfect. You can get it to 0 by zooming in and adjusting it a little bit. If I'm now checking the left side, is perfect position, tangency, and curvature. If I'm now doing that on the right side, I'm just going to the tangency, moving it a little bit more in. Now the tangency error is 0, and I got 0 for all analysis on the right side. So the reason why the mathematical analysis is now so perfect is because these control point lines are pretty much aligned the way the input has its control points. But this results, of course, in a mathematical perfect transition quality, but it also results in an unevenly distributed control point structure in the created blend. And this is causing, if you're now having a closer look, you got a wavy light line right here now. So this is, it looks like the surface would have a dent here. And this is something you, although the mathematical transition quality is perfect, you wouldn't deliver that to a customer. Because if an object looks like it has a dent, it doesn't matter if it has it or not, it looks bad, and this is something you don't want to deliver. So what I can do right now is I could, all VSR modeling functions have a local undo redo stack. So I could go now using this arrow icons here in the top right window. I can use to go back to the initial beginning. So I can get through all steps here using this undo steps. But to get back to the original shape, I can also again use right mouse button on the handles in the graphics area, use shape, reset shape, and this resets my blend to the initial shape, and I got my perfect light lens again. Okay, and this is what I want to have for the upper blend here. So I'm pressing OK, and I've filled the upper part, and now I want to close the lower part here. For doing that, I'm using a function called surface from curves. It's pretty simple. It just takes 2 to 4 input curves and creates a simple surface in between, single span, limited number of control points, and it's just position continuous, but this doesn't matter because I'm using this kind of surface to match it to all edges at the same time later on with another function. And this multi-match function is called align, VSR surface align. This is this icon here in the modeling toolbar, and what this does is it matches the surface to several input surfaces at the same time. So I'm calling the function. It asks me to select a surface to align. I'm choosing my surface, and what you're seeing right now is also something very nice. It automatically finds the reference edges which are nearby, so I don't have to select them by hand. The software recognizes, okay, there's only one edge here nearby, you probably want to match to this one. If you don't want to match to this edge which has been found automatically, you can either click here on the reference button in the menu to restart the selection for that edge, or you can, by a right mouse click on the handles again, restart the reference selection for each edge in the graphics area. Okay, so this surface here, I got only a curve down here, so this can only be matched position continuous, and I want to match tangent continuous, not tangent continuous to this side. I want to have a sharp edge here, so this will be position only 2. But the 2 other transitions to these surfaces shall be very smooth, so I'm choosing curvature continuity for them. Also again, right mouse click on the handles in the graphics area to directly choose the continuity you would like to have. And like in the blend function and like in many other VSR functions, we have an integrated matching analysis which tells us how good is the quality we've achieved. So switching that one on, we can see we've got a perfect position matching on the left and on the lower side, perfect curvature matching on the right, and just a very, very slight curvature error here, but it's up there in the corner where you probably won't see it anyway. If you want to check, of course, like all other VSR functions, you can call the light lines while still being in the function, while still being able to adjust the result, check if the error maybe is too big, and if it is, change the input parameters or the parameters of the function to get the result you'd like to have. Okay, but pretty satisfied with this result here. So just by the way, you can also switch off the analysis. If this analysis is disturbing during the light lines, you can also switch it off. Again, context menus, a lot of options there. Don't forget about that. So pressing OK right now. And what I got now, if I'm switching on the light lines again, so this part here of the side of the car is perfectly matched, nice light lines, very harmonious flow. And if you now, if you got bigger surface sets or you've finished a model and you've also modified some control points, you in the last stage you want to ensure that the model is watertight and all surface transitions you have fulfill the criteria you've got. So one thing you usually would do now in Rhino, or what you can do, is visually inspect them using either VSR light lines or the Rhino zebra function. But this is a very error-prone and cumbersome process because you really got to zoom in on every transition. You got to move the model or move the handle, let the light lines run, and just hope that you don't oversee something. And with the VSR tools, there's a much more elegant way to do this. And the function for that is in the VSR Shape Analysis toolbar, and it's called Global Matching Analysis. This is this icon here. Calling this, you are asked to select either a set of surfaces, or you can simply activate the All option, and then all surfaces of your model are inspected. So I'm selecting All. Just give me a second, adjusting some parameters here for the beginning. And if I'm now pressing apply here in the function, it takes this matching tolerance, it takes all edges, and checks now the area of these edges up to a distance from 0.1 millimeter for neighbored edges. If there are any, it checks the transition quality of all these found neighbored edges. So if I'm pressing apply right now, you see here in white all found transitions of the surfaces, and all these transitions marked up here I can now check for position, tangency or curvature. For example, I'll start with position, and I can define on my own what kind of error I want to have marked, and because I want to have a watertight model, I say, okay, please show me all gaps which are bigger than 1/1000th of a millimeter. And doing so, all these edges are marked up in red. And this is this upper edge here, and of course it is because I've created this blend here, but I didn't take any actions to ensure that the transition quality to the upper surface will be reached. So this is something now I've got to fix afterwards, what I will do now. So switching on defectives only shows you the defect edges, so making the display easier, which is only this one now. And now I'm going to match the upper surface here to the two lower ones here. And because I want to have a sharp edge here, this is the feature line, I only match position continuous. And therefore I'm using the VSR surface matching command, which is this icon here. Clicking on it, I want to do a positional matching, no further parameters so far. And I'm now selecting the edge of the upper surface, and it automatically finds again the lower reference here. But I don't want to just match to this edge, I also want to match to the other edge here. And to do so, I've got to edit the reference selection. And there are also another hint now from me. If you now just left click on the reference, you're throwing away the current selection, and you all got to select all again. So also the edge which is already selected, but I want to keep this edge. So by pressing the shift button and clicking on reference, this will keep the current selection, and it will just give me a, sorry, this been a bug. So when I'm pressing with shift on reference, I can edit the current selection. This is then I'm adding the right 1, 2, pressing apply. I just want to have a positional matching. And you see the matching is already better, but not perfect yet. And to get a perfect matching, you can do pretty much the same as in Rhino. You can say, okay, the reference surfaces I've got here do have more control points than the surface I want to match. And by allowing the surface to raise the degree, I'm allowing a perfect matching here. So if I now press apply, you see the number of control points has been raised. And now I get a perfect positional matching here. So I'm leaving the surface matching with OK. Now you see that the global matching analysis has realized now that the model has changed. It's indicating that here in the status bar on the lower side. So if I now just press apply again, it recalculates all found transitions. I can see now all surfaces are matched now under a thousandth of a millimeter, which is actually watertight. If I'm now checking for tangency, I only got tangency errors here where I want to have them. I want to have sharp lines here on these 3 lines. They shall be feature lines. I don't want to have a higher continuity there. I can also check for curvature continuity. Same, all fine here. It's just the feature lines which are not curvature continuous, of course. But if I'm being a little bit sharper with the criteria, let's say 100th of 1, you can see this here is no longer curvature continuous, and this has happened because I've made this one. I've made the positional matching from the upper to the 2 lower surfaces, and this has destroyed my curvature continuity to the right. So usually when you're doing such kind of matchings, you would use the surface align function to ensure that all surface transitions are kept. But I just want to take this opportunity to show you a very nice feature in the surface matching function itself. So I'm using surface matching again, choosing the left edge here. It's finding the right side automatically. And you see, okay, it's perfect position, and I can match perfect curvature continuity there. It's already done this. But if I'm now checking again for position continuity, you see when I'm doing now the matching to the right, it destroys the positional matchings to the top and the lower part here, of course. And there's a very nice option here in the surface matching which you should really take care of. It's called minimize changes. If I'm activating this option, not only the matching to the right is done, but the function is also trying to keep the control points in position where they are at the moment. So if I'm doing that, it tries to match curvature to the right, and you see it's getting now below the value threshold I've given. And if I'm pressing apply now, you also see that the position continuity between this surface and the upper and lower one is not touched any longer. Because of this minimized change, this is just trying to adjust the control point as slight as possible to make the matching happen. So this is a very nice option to, without using surface align, to get good matchings without moving control points too much, because you've already put them into the position where they should be. And I personally prefer using surface matching from the align function because it just gives you more control and more options than you can have than you got when you're matching several edges at the same time. Okay, so saying apply, saying OK. We now can see the global matching function. I'm just seeing we got a question here. Yeah.
It's the question why not the right surface to the left has been matched.
Yes, it's actually a good question, and this is a general rule you've got. Taking a look at the right surfaces here, you see that they only got 3 control points row in this direction and 3 control point rows in the other one. Having a look at the other surface here, you see we've got a lot more control points in the surface on the left here, because we've matched it to the lower part here. And if you're trying to match 2 surfaces, and if you have to decide which one to which to match, you should always choose the surface which has a higher control point number and where the control points are closer to each other. Because if I'm now matching the surface from the left to the right, these control points here, because they are more and they are closer to each other, have less influence on the shape. If I instead would have matched the right surface here to the left for curvature continuity, all the first, the second, and the third control point has to be moved. And this, because this is here a very long surface, this has a lot of impact of the global shape of this surface. And I don't want to change this shape too much. So if you've got the choice which surface to match, which one, take the one with a higher control point number, where the control points stick together more closely, because then matching them, it moves these control points not that much, and you are not affecting the shape as much as you would do if you would do it the other way around. So this is also a general thing you should remember when trying to make good surfaces. You have a global shape, and you're trying to touch it as few as possible. So and just to show you what we've achieved so far, I'm activating the VSR real-time renderer. We are trying to get this curvature continuity. If you get a model later which reflects, and it is the environment is reflecting on the model, you can see here now you can't tell actually where the surface transitions are, because the reflection is totally continuous. It just looks like one surface, and this is the goal you actually want to achieve, is a smooth surface set, and you only want to have edges where you really want them to see. Okay, so this is about this example. I'll now show also another one, showing a little bit of analysis. The general philosophy of our analysis is I can, for example, here create sections either through the whole model, or I can select special surfaces where I want to have sections on. I can adjust the number of sections. I can adjust the color of the sections here in the menu. I can also show the curvature flow of the sections. And I've got an auto adjust scale to put it to a sensible value, so I can decide how the shape of the surface is right here. And the philosophy of all VSR shape analysis functions is if I'm now pressing OK and closing the section analysis, it is persistent. It stays. And if I, for example, now modify the surface here with our modeling tool, you see, wait, I shouldn't use blend, but the normal option. And you see now, if I'm modifying the surface, then this curvature updates. The analysis is always instantly updating, giving you an immediate feedback of how you've changed the shape and if you have achieved what you want to achieve. I can later on always double click here on the handle to edit it, the number of sections, like, for example, I can use the right mouse button on this handle to deactivate if I don't want to see the analysis for a short time. I can also hide the handle, and if I now want to get it back, there's a central function for that on the VSR Shape Analysis toolbar. So this is an important one. It's called It's called Analysis Management. By clicking on it, in this tool here, you see all analysis you've defined so far in your model, and you can activate them, deactivate them, decide if you want to show the handles or hide the handles. You can also delete them or define new ones. So I'm keeping this section analysis active, and we also have usually other Rhino or other tools often create a lot of control points and spans, and it is difficult to work with this kind of geometry, for example. This has been created in SolidWorks, and you can see even for this simple shape we have a lot of control points in both directions, and it's the more control points you've got, the more difficult it is to handle the surface, and the easier it is to get a bad shape with that. So you want to really try to keep low number of control points, low number of spans. This can be difficult in Rhino, but if you have this kind of geometry and you got to work with that, you want to try to reduce them. And for that we've got something similar like the Rhino rebuild function, and it's called the surface approximation function. So I'm selecting the surface here, just switching off the control point from Rhino, and I'm also switching off the sections for a second because it's irritating my view here. Just reselecting for surface approximation. And also you can like in the rebuild function, say, okay, how many control points shall the result have? And you can also show the deviation of the resulting surface. So yes, I can. I'll show something on meshes with a kind of reverse engineering in a second. Just let me finish this one, and then I'll go over to that. So you can here now reduce the number of control points and see this control points here have no influence. This part here is linear in that direction. I can now deviation controlled increase the order here until I'm satisfied with the result. I'm now below a thousandth of a millimeter. I got much less control points here than I had before. And if I'm now activating the sections again, you can see already that the that the shape is a little bit smoother. So if I'm undoing the result, oh wait, I've not deleted the result. Okay, but if you get less control points, if I just doing this one again, if you got less control points, the shape is already smoother by definition. Okay, I just want to show the symmetry function here on this one, but as I've been asked to show a little bit of our reverse engineering capabilities working on meshes, I'm doing so. So working with meshes, we got a mesh of a car here, and in Shape Modeling 2.0 it's a new thing. You're selecting a global projection base if you're working with meshes. It's here inside the VSR shape options. You got a projection base. And if you click on select, I'm selecting the surface, and now you can see it has a different color, indicating that it's used as global projection base right now. I can activate or deactivate this display if it is disturbing. And if I'm now calling, for example, I've got several functions now to create geometry on this mesh. The most simple one is the surface from points. I can say that I want to use the global projection base or not. Right now I want to do that, and then I can pick 4 points on the mesh. I've got an integrated deviation analysis telling me how far I am away from the mesh. And I can also move the handles here on the mesh to the positions where I want to have them. And now you see I've created now a surface with a chosen degree just on the mesh. So this is by 4 points, but we also got a lot of other options. For example, we got the surface on mesh function. The surface on mesh function, you select the mesh, and then you select a point on the mesh, and it's then selecting a flat area, so an area of same curvature. It's based on this angle you can enter here, and I can click several times here to define an area where I want to create a surface. I can then choose to either use extrapolate surface when it is created and is covering the whole red area I've selected, or I can choose without extrapolate surface, then it is created inside. So let's choose inside for the second here. Usually when you're working, you've now created surface on the mesh, but you usually want to also modify them, rearrange control points, change the shape, and for that you usually want to know how far you are away from the mesh, and therefore you can use the deviation analysis here in the shape analysis toolbar. Starting that, I'm selecting an object, which is the surface, and the reference, which is the mesh. And now I've got a persistent deviation analysis always telling me if I'm modifying the surface, how far away am I from the mesh. I'm just interested in the max value, so I'm just deactivating the show min. I'm also doing this for the lower surface here. And now what I can do now, if I'm using control point modeling to modify this surface, if I'm moving away a control point from the mesh, you can see the analysis updates and tells me how far away I am from a mesh. Okay, usually of course you want to stay on the mesh, and in control point modeling you also got the option use projection base. If I activate this, the whole surface is projected onto the mesh. And if I'm just making it here a little bit smaller, and if I'm now choosing to modify a single control point, I can only move the control point on the mesh. I can't move it away. It's always being reprojected on the mesh. So I can use this option here to rearrange my control points, get a nice equal distribution I need for nice light lines. I can shrink the surface, and it's always staying on the mesh. Okay, we are slowly coming now to the end and the start of the Q&A session. So maybe we should now, just go over and answer some questions. So Kevin, you wanna pick some, or Peter?
Yeah. Yeah. Hello. All right. So let's start from the top. How about that? So I know that Peter answered some of these questions, and I'm sure some of the attendees can see it all as well. But let's do some on the air, just to so that people can actually hear it. So let's look at Vladimir's question. These values are indicative of the level of tangent or curvature different from Catia values or alias. In other words, the curvature of the value of 0.1 in the VSR corresponds to 0.1 in the alias in Catia. Peter, would you like to give this one a try, or?
It's all CAD systems got, as far as I know, got a different definition of G2. I mean, I can give you the formula in ICEM Surf and Catia. It's a little bit more strict. It's more easier giving you the one, even if the light line. So the maximum error in G2 is always 1, but you can have different definitions of curvature in the mathematics. So we are using a different one than ICEM and Catia, but it's still pretty close. And the reason why we are using a different one is you can have, if you're measuring G2 to a very flat surface or planar surface, it is very easy to get the maximum error while the surface transition is still good. So the light lines look great, but you still get a G2 error of 1. And trying to avoid that, you can have different mathematical definitions of G2, and you just want to have this kind of definition to make sure that if G2 is alright, then you've got good light lines, of course, this direction. But you also want to ensure the other direction. Well, if you always have a G2 error of 1 while the light lines are good, this is not a good definition of G2 then. So I can't give you the exact formula at the moment. I can just say it's a little bit different. I can send it to the people if they're interested, but I can promise you it's very mathematical.
Cool. Okay, Vladimir, if you're interested, please contact Michael at VSR, okay? Moving on, John wants to know, is it appropriate to discuss the use of the adopt option in the surface align tool?
The adopt option is the same as the adopted option in the surface matching. And what it does, maybe I can just show it here on this example here. So we got here, you're seeing this control points here, and I can now let me just move some control points here so they are unequally distributed without projection base. So you can have a surface like this one and you want to match it to the other. And without adopt, I'm just choosing position. Oh wait. Just choosing position, matching this one to that one. You will see that the control points stay the way they are. If you're now activating the adopt option, it says, respect the control point distribution of the reference and try to get the same distribution. And doing so, it then moves the control points of the matching surface so they go over onto the right position into the reference surfaces, usually achieving a better transition quality. This is what adopt is doing. So it takes care of the control point distribution of the reference. While adapt also says, okay, not only take care of the distribution, but also raise your degree and the number of spans to the one of the reference, so you can make sure you get a perfect transition, because every control point on the matching surface is matching to a control point on the reference. Okay?
Cool. All right. Thank you, John. If you have any more questions, send them to the chat window. Dave wants to know, can you work with meshes, scan data, for example, I guess?
Didn't get the last one. Can we work with meshes and then what? Sorry?
Can you work with meshes and scan data, I guess?
Scan data. I mean, we can use them as a reference, and the only function we've introduced so far working with meshes is if you got very big meshes and you want to concentrate only on a little part, the selection option you've seen in the quick surfacing, we have the function submesh creation, which where you can trim. So I can select, like in this quick surfacing tool, I can select an area on the mesh. I can then decide to trim or split the mesh at this area, or I can also create a new mesh. So if I'm now choosing a new mesh, I've now just created on this area a new mesh. I can hide the rest, and now I can work just on this part here if I like to. And I can also, instead, I could say, okay, I want to work with this part and the other part later. I can also say, okay, split the mesh, and then you'll get two parts. And I can also trim, just keeping one and throwing the rest away. This is the only tools we have so far to edit or create new meshes. And then for the rest of our functionalities, we are just using meshes as reference so far. Okay.
Okay. Also, here's another one. Can you do curvature analysis on the mesh? In Alias, I use this to lay out my primary surfaces. This is a question from Dave again.
It's not what you usually want to have is a smooth value, and we've been thinking about that, and might come earlier or later, but right now all you've got is the section analysis, and if you take a look on the curvature analysis on a mesh, it's always got this real big peaks, and you want to have this in a smooth way, I guess. This is the question, right? And yeah, this is something we've been thinking about. We've heard this request. We can't do that so far, but it's on our list. I'm pretty sure it will come earlier or later. Okay.
Cool. Okay, Peter has this question about, is there some way to change the color of section on the mesh and surface? He uses this function in ICEM very often.
You can't do that by just saying, okay, I want to have this kind of section color for meshes and this one on surfaces, but you can of course just say, okay, I want to select, I'm just selecting a mesh for X sections and choose them to be blue, and then I can just create the same sections and then just select the surfaces and they shall be red. So there's not an option yet to say, okay, I want to have the same section red on meshes, blue on surfaces, or the other way around. Yes, it could be implemented if there's a need for that, but we don't have it so far. You've got to handle it via selecting them for different section analysis.
So just an idea.
I'm handing over to Peter. Give me a second.
Just an idea. I think a way which would fit very good to Rhino is, for example, if we could allow that the section take automatically the colors from the layers. So if you would put the mesh to one layer and the new created surface on another layer, they would automatically have different colors. Just an idea to implement it.
Okay.
Cool. I guess we're moving on. Here's another question. Can you get a color map of the deviation between the surface and the mesh versus section lines?
Color map again of a surface
of the deviation.
And we have implemented a colored deviation analysis from a surface to a mesh in the current version. It will come in the next version. I could install now the new software. It is already available in the development version I've got here. Yes, we got that. Will be in the next release.
Cool. Okay. Can you make a surface from points only? Here's another question.
Can we make a surface from what? Sorry?
From points only.
Kevin?
Hello? Yep.
From points only.
Yeah.
No, we need triangulated meshes so far.
Cool. All right, and this is from Victor. Hello there. Which is the best density of triangles for a scanned mesh from a 3D scanner? He's using a Next Engine scanner in order to work later for creating surfaces.
Very specific question.
Yeah.
I mean, this is well, yeah, it's difficult to say. I mean, of course, if it is dense, it is always if you got a dense mesh, you got to filter it later on. But it's always, this is an option you can't put on points later. There's no general rule for that. At least we don't know one. It's got to be just good enough. I mean, not sure what the shape of the object is precisely, but as long as you can find the contours, you can see them on the mesh, it will be fine. No general rule. I'm sorry.
Cool. Okay, this is from Nim. In Catia, you can match a surface projected on top of another without trimming. Basic matching on top of a surface instead of the edges. The question is, are you guys planning a tool like that?
Kevin, I pretty often.
Yeah.
Yeah. Okay. I'm pretty often you're just gone in the later part of the question.
Okay. Sorry.
Basic matching on top of a surface instead of the edges.
Yeah. So in Catia,
basic matching on top of a surface. Yes, this is also implemented. If you got a surface and you want to just match inside the other surface, this is also already available in the version we are developing right now. So it will be in the next version next major version we are releasing. This will be in, yeah.
And so this is the fourth quarter 2013 version 3.0, right?
Yes.
Cool. Awesome. Peter?
Maybe just a sentence about our release policy. We typically bring out one major release per year, and always in the fourth quarter. That means in November we brought out the Modeling 2.0, what we are just introducing right now, and this year in the fourth quarter we will bring out Shape Modeling 3.0. So in summer there may be a better version available. Between the major releases, from time to time we are bringing out update releases. They are free of charge and running with the same license as the previous major version. So for example, for the Shape Modeling 2.0 we have already 2 updates. That means if you go to our download site, you will find already the version 2.02. So only some minor bug fixes and no functional enhancements.
Cool.
It's just about our release policy.
Cool. Thank you, Peter. Norbert wants to know, can you tell us something about the coming fillet functions?
The planned functions for the next release and the major ones?
Yeah, the coming fillet function.
So yeah, this is the next big 2 function. Yeah, it's the fillet and smooth command will be in there, yeah, and we're also implementing a non-splitting trimming function because the Rhino one can cause problems. So we'll implement a one, yeah, creating smooth edges where you can work with without problems. So yeah, fillet is planned as the next one, smooth command and facing, or like in Rhino said, split trimming.
Okay, cool. All right, so this is going to be our last question for our Q&A. Dave wants to know, is there a function similar to the detach command in Alias?
What is, and therefore I got to know what the detach command is doing. I don't know that one in Alias. I mean, we've been implementing functions for Alias, but we're not familiar with the Alias naming. So I need to know what the detach function is doing.
Okay, all right, one more question. I think this one's important too because, this is a really cool package that you guys offer. Will there be a beta user of the new release? I guess, will there be a beta release, I guess?
Yes,
yeah.
For sure. And we usually share this with our customers, but if people are interested to be beta user and if they are providing good feedback, they can, yeah, of course, participate in our beta user program. Yes.
Cool. Okay. I guess we'll switch the presenter back to me. That basically sums up our Q&A session right there, guys. Cool.
Okay.
I think I'll do that.
Just did it.
Oh, yeah. Cool. All right. Do you guys see my slides here?
Yeah.
Awesome. Okay, so on behalf of the Novedge team, thank you for attending this awesome webinar. Thank you, Michael. Thank you, Peter. You guys shared the mic, but you guys definitely also answered a lot of the technical questions that I could not do that myself. So if you guys, let's see. If you guys are interested in learning more about VSR and what they're doing there, head on to www.virtualresearch.com, Virtual Shape Research. There's a ton of information gallery. You could check up on the latest events and also check out support information as well. Learn more about the company. Definitely head over there. If you are interested in purchasing a copy of Virtual Shapes, VSR Shape Modeling 2.0, we just want to let you know that it is also available from us at Novedge.com as a digital delivery and available worldwide with zero sales tax. Michael, do you have anything else that you want to say? I think you're the expert, so put it in your own words.
No, I just want to say thank you for everyone participating. I think you're aware if you have any unanswered questions, you can just send them to me so I can answer them via mail, right? So nobody leaves here without getting his questions answered in the next days.
Cool.
Okay,
definitely
perfect.
Feel free to, yeah, go ahead.
Okay, if you can send them then to me, then thank you all for participating. I hope we've shown something being interesting for you. And yeah, if you want to give it a try, the installation comes with a 3-week test license. Yeah, and if you got a valuable input, if you want to see something implemented in our tool which fits into our philosophy of creating high-class surfaces in Rhino, just let us know. We're always open-minded. We want the user input. Just give it to us, and looking forward to you using our product and making it better together with us.
Cool. Awesome. And I think another way that you guys can contact the VSR staff is by heading on over to rhinojungle.com. I'm going back in the slides. Oh my gosh. All right. So head on over to rhinojungle.com. I know that one of the members, one of the founders, I think Horace or Michael, they're actually on rhinojungle.com. So you can check out, send them a question there, and we'll probably be, there's a lot of developers that are, they have a presence there, and they can answer your questions as well. Let's see. So in our next upcoming webinar, I just want to let you guys know that Brian Benton, the Autodesk Expert Elite and Catalyst contributor, will be on hand to basically show you how AutoCAD sheet sets can do more than print your drawings. See for yourself how powerful it can be as a project management tool. So if you want more details on this webinar, check out the webinar page at novedge.com/webinar/67. All right, and if you missed something, you want to rewatch this and other past webinars, feel free to check out our Novedge webinar series channels on Vimeo and YouTube as well. All right, and on behalf of Novedge, thank you guys for joining us today, and we hope to see you guys all next time. Michael, thank you. Peter, thank you. Attendees, thanks a lot for showing up. All right. Cool.
Yep, thanks a lot for giving us the opportunity to be here.
It's all good. Cheers.
Okay, have a nice evening. Bye-bye.
Bye-bye.